Hi, Assalamualaikum. Today my group will present to you about lab 6, which is Z transform.
Assalamualaikum warahmatullahi wabarakatuh. In this video, we will explain to you the result of lab session 6, Z transformation. For question 1 is Z plane of the system. For question A, the discrete time system given is Hn is equal to negative 1 over 3 bracket 1 minus 1 over 2 Z power of negative 1 Un minus 4 over 3 2 power of n Un. To transform the discrete time system into a Z transformation, we refer the Z transform pair table. And then we get the Z transformation equation. After that, the equation is timed with Z over Z to simplify the equation. Then we get negative Z over 3Z minus 3 over 2 minus 4Z over 3Z minus 6. And then we factorize the equation to get more simple equation. So the final equation for Z transformation for system A is equal to negative Z over 3 bracket Z minus 1 over 2 minus 4Z over 3Z minus 2. Now I explain to you the simulation for question A. First, we declare the symbolic variable n by using sims command. After that, we declare the system function of system A. And then we use command hz is equal to z trans h to perform Z transformation on the discrete system H. After we run the simulation, the command window will show the Z transformation equation for system A. So hz is equal to negative 4z over 3 bracket z minus 2 minus z over 3 bracket z minus 1 over 2. The Z transformation obtained from the simulation is same as the Z transformation that obtained from the calculation for system A. For question B, the discrete time signal given is Hn is equal to bracket 1 over 2 power of n Un minus 1 over 4 bracket 1 over 2 power of n negative 1 Un negative 1. We transform the equation into Z transformation by referring to Z transformation table. So this is we get after we refer with the Z transformation table. After that, the equation is multiplied with Z over Z to simplify the equation. Then we get the final Z transformation equation for system B is equal to Z over Z minus 1 over 2 minus 1 over 4Z minus 1 over 2. For simulation for the question B, the simulation is same as the simulation for the question A, but the difference is that we change the system function into the equation of system function B. After we run the simulation, the command window will show the Z transformation for the system B. The Z transformation for the system B is equal to Z over 2 bracket Z minus 1 over 2. So the Z transformation obtained from the simulation for question B is different with the Z transformation that obtained from the calculation.
The calculation in part 2a was to find the inverse transform with traditional transform pair, along with additional algebraic manipulation and several Z transform features for good measure. The Z transform pair table was obtained by simplify the denominator and get the value of Hz over Z. Then, the partial fraction has been used to find the impulse response of the system. By using inspection method, each term of the partial fraction was inversed and transformed, and the final answer was obtained in the Hn. For simulation, by using MATLAB command of SYMSZ was used to find the inverse transform for the IIR system. Then, the command for IZZATRANSH was obtained to perform the inverse Z transform on Z-plane system. This concept was same as calculate manually. The step to find the answer in calculation for part 2b was same as part 2a, but both values of calculation and simulation were different. The final value for the causal Signal in MATLAB was always causal.
Part 3a, from the LTI system equation given from the lab sheet, can get the plot of the pole and zero system by getting the equation for hz equal to yz per xz. And the equation is simplified to be like this. From the last equation, can get the value of zeros, which is 0 and -2, and poles, which is 1 per 4 and 1 per 2. From the value is used to form the z-plane. For simulation, this is MATLAB coding to get the z-plane of MATLAB. This is the result that get from MATLAB. For B, using the equation hz can be used to determine the system impulse response if it is causal by obtaining the equation yz equal to hz. Then simplify it until it becomes like this. Finally, convert it into an impulse response form. For simulation, this is MATLAB coding, and this is the output for the response impulse that get from MATLAB. Lastly, for C, the output signal are depending on the value of the input signal, which is causal system. All the physical system are causal system and only respond to input after the application of input. There are two different causality, including causal and non-causal. Non-causal system are a system that is not physically realizable.
That's all from us. Thank you.